Thanks for joining. So I'm talking about monitoring tracing via OpenTelemetry. Let's just look at the current state. So the current state is with CAP out of box. We offer Kibana logging for production scenarios, and then also, let's say, a basic Dynatrace integration. You can use the one agent if you inject an environment variable, and then monitor the application via that. But both are not really sophisticated to monitor the whole application. And that's what we wanted to tackle with OpenTelemetry at CAP. So the end goal is, of course, to have an observability about your application, because in the end, you have to be cost efficient. And you also want to avoid errors that occur in production that they don't get escalated by customers. And then also for golden signals, those KPIs are already provided by Kibana, but can also show up in Dynatrace and are quite nice. And usually observability, to have a good understanding of your app, you have logging, tracing, and metrics. Logging is already done with Kibana, and tracing is now tackled with OpenTelemetry, what I'll show. It's still a lab preview, but will probably also come out later this year for public consumption. And metrics will follow. So you have currently some basic metrics, but for example, I think if you manage production applications, you probably will have faced HANA pool issues, and metrics about those will be helpful to identify issues upfront. And that's what we want to provide with metrics later. But yeah, first, what's OpenTelemetry? So OpenTelemetry is an API definition. It's open source and vendor neutral. And it supports as well, so Dynatrace as a collector, but also other monitoring services. For example, Jaeger as a collector, or Zipkin are some open source ones. And it's just that with the current integration in only Dynatrace, it's not really great for CAP, because when Dynatrace gets out of favor and you have to use another service, then CAP would have to re-implement everything. So now we switch to OpenTelemetry to avoid in the future vendor agnostic logic. And yeah, OpenTelemetry also has automatic instrumentation for frameworks like Spring.NET or Express. And in our case, we leverage actually the basic instrumentation of Express, and then do something for CAP in specific to have greater insights. And yeah, the definition itself is for traces, metrics, and logs, but for Node.js itself, it currently only is feasible or is usable for traces and metrics. So logs might come in the future with OpenTelemetry, but not now, right? Not right now. Oh, not that slide. And now demo. The demo part. Let's switch the screens. Duplicate. Perfect. Let's go into, where is it? VS Code. So you may have seen the app from earlier. It's again the data retention manager test application, and for that one we've also enabled OpenTelemetry. It's basically, for enabling, it follows the same plugin approach. So you just add SAP CDS OpenTelemetry, and then ideally it works out of box. If not, you can also have this. So under CDS, you can have plugins and then define this line or include this line, and the plugin will be loaded. And maybe we just restart shortly to show how it will look. So you will see here loaded plugin. So this is the data privacy plugin, but the next one will be OpenTelemetry. It takes a while because especially the Express instrumentation is quite expensive when starting. You see loaded OpenTelemetry, and then in it. Yeah, also a great package. So if you use it SAP CDS Common Content, it increases startup time, but you don't have to worry about managing the set. And so if you refresh now with localhost and go back into the IDE, so in the default, you will see that the traces show in your console. So if you just enable the plugin, it works out of box and gives great insights. So the numbers are currently a bit wrong because something changed with OpenTelemetry. But essentially what you see is then all the events that happen. So you see here get books with the initial request, and afterwards, so there was executed, or there was a begin statement for the database, a read statement, application service handle, and then a commit. those are not in the correct order, sadly, in the console. But we can change that if we export the traces, for example, locally to Jaeger. So Jaeger is is an open source collector. And you can just run it as a Docker container and then export your traces into there. Whereas going back, I can already show you Jaeger. So basically, it looks like this, quite nice for local development. And you can then inspect your traces. For example, this one is from earlier. And if I click on it, I see the same request, but now also in the correct choreography. So I see that the handle request was, or the handler from CAP, or the handle function handles requests. And within that, I emitted an event and had the begin statement and read statement for the database, and then later on a commit. So that's also quite nice to find issues, or if you have any issues with performance, to find the bad guy. But yeah, let's show what's also capable with the package. So you can, via the log levels. So for simplicity, we just shared the same, or we used the same API for traces as log says. You can just enable for app traces by setting the log level to trace. And then if you restart, you have further insights. So the app flag will be responsible for handling all traces or tracing all handlers. So if you have a complicated application with registering 20 or 30 handlers and you don't know which handler is causing the trouble, the package might be really helpful, because you can then see which handlers are executed, how long do they take, and also if an error occurs, in which handler did the error occur. So if you wait a moment, perfect, and then send again a request and go back to Jaeger to inspect. You can see we have this one now, and here you see that out of box CAP already has quite some handlers registered, but I can also see if I, for example, have here custom handlers, so I have my own read handler and my own after handler. Those are also listed. So for example, here the last one is then after read, and if I press on it, I'll see also that the path goes to my file. Maybe one more thing that's interesting to know is if you don't export to Jaeger, but instead have the traces locally, we actually will also show the direct file path, so you can just control click on it and end up in the correct handler place, which is a lot or even easier for debugging. And while it restarts, I can also show the emit support. So obviously in your CAP handlers, you will have asynchronous events or CDS spawn usage. And yeah, let's just implement that in our bookshop. So, and my test, and then in our bookshop service, we register an on handler. And just execute something. You could also execute then inside of that the CDS spawn or so, and then have even further asynchronous operating. And yeah, just for demo purposes, maybe in the after read, we have a CDS spawn. So that's also a performance benefit. Whenever you have like things with scheduling notifications, you should always use the CDS spawn to do the whole logic for sending the notifications, else you will block the response time and your customers will complain. And in there we just do a select from books. And now it started again. So if you do a request, we can first show that with the handlers in the console. So here you see again all the handlers being traced. You see CAP out of box already registers quite some handlers, and that's on our radar for later this year, that the registering is improved. For example, a common generic temporal is one that will be probably not be on each entity in the future, because the books entity doesn't have temporal data, so the handlers are necessary. But here on our own handler, we have the path at the end. So if we click on it, we end up in the handler and can directly check what's going wrong if something goes wrong. And for the sake of demonstration purposes, let's add back the export to Jaeger and restart again to show the thing with asynchronous operations. So for the long startup times. Yeah. And maybe what I can also tell is, so we have an annotation, also CDS, I think it's CDS trace, with which you can annotate your services to either exclude or include services depending on your default settings. So in larger applications, you might just want to trace one service. So then you by default would disable tracing and only enable it for that particular service. That's also possible. And with environment variables from OpenTelemetry, you can also set up things like how many traces do you want to receive. So if every second trace is already fine and you don't want to have too many traces, then that's also possible. And let's schedule another trace and look at the latest one. So here we see this is the one where, is it the one? Yes. Here you can see in the after read, we schedule the CDS spawn, and somewhere here is also service emit, or did I forget to schedule to send service emit, didn't I? Yes. Yeah. So of course to emit an event is also helpful if you want to demonstrate it. But CDS spawn is also sufficient. So they have the same logic in the background. And basically, you see then CDS spawn is executed in here. And if you go back, CDS spawn itself will be then its own trace because it's asynchronous. But in the top level, you will have a reference back to the span that caused this CDS spawn. And then you end up in this trace again to have a full level compliance. And in the text, you also have, maybe not locally, but in the deployed versions, you have the tenant ID and the correlation ID. So you can also trace across systems as sufficiently and analyze it. Yeah, and that's the part I wanted to show for logic. So the thing we also did is an automatic integration with a Dynatrace. So if you have set up Dynatrace under distributed traces, it will, if you have the one agent, then it automatically will connect. And you see, for example, here with DRM again, a successful request. It basically looks as in Jaeger, but it's then Dynatrace. And you also see the middlewares. So it's Express. So there are quite some middlewares, for example, enforce login or context auth. And later on, you see then the, for the small window. If that one was that's correct. But you see essentially the same trace. But what I wanted here to show is you will also see the errors. For example, this request failed. And if you scroll down, you can see then the sensitivity is quite strong. But you can see read HANA Cloud, and in here you have then errors and can see what went wrong. Cannot build SQL invalid CQN, and then you know the root cause, which part caused it, and can properly debug. Yeah, and that's basically it. What I wanted to show. Let's go back to the slides. Now, if you have any questions, I would open it up for questions. And thanks for your attention.
Thank you, Martin. Question. Well, many questions.